watch the video on the previous, from the previous class on absolute value limits. Okay, where is the starting point? Anyone?
You use the 0 from the x goes to 0 by putting it into the x.
That is correct. In any other situation without a function, having a just decent function, so to speak, I would have done that first. That's exactly what I said. I have to plug it in. I completely agree. Not in this particular situation. I'm not changing the rules on you, but certain functions are exceptions. So this is an exception. There is no point in this case in plugging in 0. Not before I completely simplify the function without absolute value. So yes, I'm going to say yes, that is in general what we need to do, but not for this specific special case.
How would we know for this specific special case then?
It's a special case because every time we see an absolute value, we know there are two possibilities. This is not a simple function. Absolute value has two faces. So I don't know what the situation is here then. So where is our starting point? Exactly, if you watch the video from last time, that's exactly what we did first. We did not plug in anything. We didn't plug anything in. We started where? Anyone?
Did you define the two different possibilities of?
Yes. Where is my starting point? Absolutely correct. But what do I have to write first? Where is my next step here?
Don't you have to carry down the limit? Like
I covered the limit. The limit does not exist at this point. It's not even there.
You define the values of positive x and negative x, or is that absolute?
So the starting point is exactly, tell me what to write. But how do I start? What do I have to write here first? What do I have to analyze first? What is my first line of thought? Next step.
Would you?
Isaac?
Go first?
Go ahead. It's okay if you're wrong. We are discussing this.
Okay. Would you want to break down the absolute value?
Absolutely. This is my starting point. That's all I see at this point. Excellent. Great. So now can anyone continue?
And you would write your x, if x is greater than 0.
Excellent. Great job.
Yeah.
Now,
would you write the equal to?
I cannot write it in both. I can only write it in one. It will not be a function if I write it in both.
Okay.
Now the question is, do you want to keep it here or here? It doesn't matter. You can keep it here or here, but not in both.
Okay.
Perfect. Okay, so now we move on to what? After we establish this.
Since x is approaching 0 from the right, would be.
We are not there yet. The limit is covered.
Okay.
I don't even have the limit. I don't even know what's underneath there. I'm way far away from that point. What is my next step?
Is it a f over x?
Exactly. So I have 1 over x minus 1 over the absolute value of x. If this piece has two pieces, two possibilities I meant to say, then the whole function has two possibilities. What is the first possibility? With no calculations, that's just tell me what to write first for everyone to see.
X if x is greater than 0.
So you're talking about this. But what do I write? I completely agree with this. Because x now is in the denominator, so I cannot have 0. Awesome. But what do I write? I'm
Over
sorry?
Here, you just say 1 over x minus 1 over absolute value of x.
But I already put it in two different pieces. This is gone. I'm done with that. The absolute value is gone. It has two different possibilities.
You just
So
say
1
one
over
over
x
x.
minus 1 over x.
Correct. That is perfect. What is the other option?
1 over x minus 1 over minus x.
Exactly.
Or you just plus, yeah.
Excellent. For x less than 0. Awesome. Good. So what is this then?
One on the top
This branch, how much, what is that? What does this equal to?
is 0.
Very good, for x greater than 0. And what does this simplify to?
2 over x.
Very good, for x less than 0. Now I'm looking at this. Only now. And I will copy limit as x approaches 0 from the right. And now you pick the correct branch.
Let's go with the first branch because it's greater than 0.
Very good, because it's to the right-hand side of 0. And what is the answer?
0.
Excellent. This is it. But you have to watch the tapes. From one example, without rewatching it, it's not for everyone. This is for everyone. I'm not talking to any one of you in particular. Good. Good question. Next one. Anything else that you want me to show? Anything else?
Number 40. Oh, no, I'm sorry, not number 40. Number 34.
Number 34. Same section?
Yes, 2.3. Everything's
Good.
2.3.
Before we do this, anyone has any questions on this work? Do you understand why we had to start with the absolute value? Because this piece has two options. This piece does not have two options. This is just 1 over x. No one can change it. But 1 over the absolute value has two possibilities. Or basically, the absolute value has two possibilities. Therefore, the entire function has two possibilities. But I have to break down what has two options first and then incorporate that in the function itself. I hope that this is clear now. Okay, you said 34. Let's look at 34. Where are you, 34? Okay, here it is. So this is limit as h approaches 0 from 1 over x plus h everything squared minus 1 over x squared divided by h. We had a couple of similar problems with this when we determined the difference quotient. This is a difference quotient of 1 over x squared. Okay, first step. Anyone?
You have
Least
to
common
define.
denominator.
Now, indeed, I do have to plug it in. I don't have any options at this point. This is a simple rational or complex rational expression. I do have to plug it in. There is no way around it. Where does the numerator go?
It
0.
is
Excellent. Where does the denominator go?
0.
Excellent. So there is hope. Good. Very good. So I already heard somebody say I have to find the least common denominator. So this is h or h over 1. Very good. Awesome. Can anyone give us the least common denominator in the numerator?
It would be x squared times x plus h squared.
Excellent. They have nothing in common. It has to be the product of the two. Who said that?
You know,
Thank you. Good. So now what do I need to multiply the top of this by, and what do I need to multiply the top of this by? This is not a fraction line. This is just a reminder.
the first one will be x squared.
Excellent. And the second one?
X plus
Okay.
h.
Exactly what it does not have, of course. Good. So 1 times x squared is x squared minus, can anyone give us, we talked about this on the first day of classes. Minus, I will put parentheses for everyone to see what's happening here.
Squared plus 2xh plus h squared.
Brilliant, thank you very much. You made me proud. Okay, so this is limit as h approaches 0. I will distribute and also flip the denominator at the same time. That's what lazy people do. Try to do 2 things in one step. So then I have x squared minus 2xh minus h squared, and I copy the denominator. If you need me to write this note, I can. Do not expand the factors in the denominator. Do not leave it alone. We need it factored. Factors in the denominator. Since this, we know it's the difference quotient, not with a limit. It's the difference quotient. We know that what has to happen at the top?
Your x's should cancel and you should be able to factor.
All terms without h must simplify. And then eventually this must go away with a factor from the top. I'm going to put a circle so you know it continues somewhere. And now please tell me what to write next.
In the numerator.
So I have limit.
2x h squared.
So we factor out negative h. And we have h and x squared and x plus h squared. And let's see what is left. 2x plus h. And as planned, goodbye, Mr. H. Now I drop the limit operator because I apply the limit operator or the limit to the function. What do I get? Let's start with the numerator. Of course, I have to copy the negative sign.
Negative 2x for the numerator.
Very good. I already put the minus in front of the fraction line. Good, 2x. What about the denominator?
The denominator would be x to the 4th.
Excellent. I simplify 1x and I get negative 2 over x cubed. Good job. Any questions for me? Anything from this or anything else? Is there anything else from anything? Can I continue? You can still stop me anytime. I'll stop what I'm doing. If you remember about, a question or anything, I'll stop anytime. Is there anything else? Okay then, so I'm going to share my screen and go now to 2.4 to finish that up. And I would like now to look directly at, we can choose other problems if you want. The problems that have the symbol cannot be determined without a calculator of some sort. Okay, so remember that. What I'm interested in is something like this, from 15 through 22. X squared can be, x cubed can be, all these can be done, but they require a lot more work. So I'm happy you're not going to see this proof again for the entire course. This is it. So if you understand how to prove using the epsilon delta definition any of the linear functions, I am absolutely happy and pleased. So let's choose any function you'd like from 15 through 22.
What about 19?
Let's start with 19. Let me copy it so it's limit as x approaches 9, 1 minus 1/3 x equals -2. Okay, perfect pick. Let's start. Now, first of all, I'm not asking you to stop believing everything or checking everything, but we have to do that. So when I plug in 9, because it's a linear function, I'm allowed to plug in. Although x does not equal 9, for linear functions or polynomials, I'm allowed to do that to determine the limit. 9 divided by 3 will be 3. 1 minus 3 is indeed -2. So now I have to start by writing the definition. So we're going to pick another problem, or maybe even two if you need to. So just bear with me. We have to write the double equivalency symbol. In other words, this implies this, and what I'm going to write on this side implies this. And because I don't have enough room, I'm going to start here. For every epsilon positive, I will find the corresponding delta positive such that every time I pick x minus the distance between x and 9 less than delta, this will always imply the f of x, which is this, the distance 1 minus 1/3 x minus the limit. This is the limit, and this is a and the limit. Okay, let me do it like this so you understand. Okay, minus -2 will be less than epsilon. And this mechanism works for every epsilon because the limit exists. It's -2. For every epsilon positive, I will find a corresponding, there exists a corresponding delta positive such that when I pick x close to 9, why 9? This is a, close to 9. X approaches 9, x is close to 9. When I pick, so that the distance between x and 9 is smaller than delta, the distance between f of this x and the limit will be less than epsilon. F of x minus -2, this will be the distance between f of x and the limit, will be less than epsilon. Okay, first step, we start here. This is the starting point. Okay, of course I'm going to say 1 plus 2 is 3, absolute value, minus 1/3 x less than epsilon. Looking at this inequality, what should I do? What do you think we should do here? Just a wild guess.